Hello friends, let us learn about distribution systems. Topics to be covered: classification, functions, major components of substations, feeders, distributors, service mains, radial and ring main systems, calculation of voltage in distributors with concentrated and distributed loads, single phase AC distribution systems and three-phase AC distribution systems. Major components of substation: lightning arresters, conductors, insulators, instrument transformers, electrical power transformers, relays, circuit breakers, bus bars, capacitor banks, isolators. Functions to be explained here: electrical substations, interface that lies between transmission and distribution systems, designed to reduce voltage in transmission lines to a level that distribution systems can withstand. Inbuilt circuit breakers protect the distribution system and also manage the current flow in the different directions. These also manage fluctuations in voltage to manage heavy loads. Classification of substations: three types: transmission substation, distribution substation, converter substations. Transmission substations usually transformers between the voltages, capacitors, reactors and other equipment that can manage power flow between the systems easily. Distribution substations get at least two transmission lines and the output is easily through a number of feeders. Converter substations associated with traction current and HVDC converter plants. The converter substations comprise powerful devices that can alter the frequency of the current running through the system. Feeders: feeder carries energy to a substation or a bus or several loads. Feeder may connect two substation buses in parallel to provide stiffness or service continuity for the load supplied from each bus. Feeders are the smaller electrical lines feeding or leading out of the main power bus. A power transformer reduces the voltage from the higher levels used in the transmission lines to the levels where it can be used. 11 kV lines are used in residential areas and what feeds the local transformers, which then distributes power to the buildings in the area. 33 kV lines, on the other hand, involve much higher voltages and are used to distribute power from one small substation to another. Distribution and service mains. Distribution systems is a conductor from which tappings are taken for supplying to the consumers. AB, BC, CD, DA are the distributors. Current through a distributor is not constant because tappings are taken at various places along its length. While designing distributor, voltage drop along its length is the main consideration, since the permissible limit of the voltage variations is plus or minus 5% of rated value at the consumer terminals. Service mains is generally a small cable which connects the distributor to the consumer terminals. Radial and ring main systems. Radial systems: primary main and secondary mains in between fuses, primary side distribution transformers connected, secondary fuses connected with the service to the consumer's part. Ring main systems: feeder in closed loop connected with the number of loads with the distribution systems along with the transformer connections. Calculation of voltage in distributors with the concentrated loads. Concentrated and uniform loading with the distributor fed at one end. Different types of load settings they are given here, and next diagram it will show for that branch currents. Adding of that branch currents A point to B point. First diagram solution. First consider drop due to concentrated load only. So drop in PA equals to 150 into 100 into 0.005 equals to 7.5 volt. Drop in AB 110 into 50 into 0.005 equals to 2.75 volt. Drop in BC equals to 90 into 150 into 0.005 equals to 6.75 volt. A drop in CD equals to 30 into 100 into 0.005 equals to 1.5 volt. Total drop due to this load equals to 18.5 volt. Let us consider drop due to uniform load only. Distributor fed at both ends with equal voltages. Figure shown in figure 40.A. Distributor fed at 2 points F1 and F2 with equal voltages. The potential of the conductor will gradually fall from F1 onwards. So each reach a minimum value at one of the tappings, yeah, and then rise again as the other feeding point F2 is approached. AC three-phase distribution systems. Diagram A, consider for delta connection, phase voltages equals to line voltages. Diagram B, connected with the star connection, line voltages equals to square root of 3 into V phase voltage measurements. 3-phase power measurements, 3 phases drawn here. Each phase have 120-degree phase shift. Calculations, power in DC circuits. P equals to V into I. P equals to I squared R. P equals to V squared divided by R. Power in AC circuit, single phase. P equals to VA cos theta. P equals to I squared R into cos theta. P equals to V squared by R into cos theta. Power in AC circuit, 3 phase. P equals to root 3 into VL IL cos theta. P equals to 3 into V phase I phase cos theta. P equals to 3 into I squared R into cos theta. P equals to 3 into V squared divided by R into cos theta. Friends, I hope you could understand this video. Thank you.